Hello, so today we're going to be looking at problem solving using highest common factor and lowest common multiple. I'm going to start off with the highest common factor. So if we look at question 1 here, Liz has two pieces of string, one is 18 centimetres long and the other is 24 centimetres long. She wants to cut them up to produce smaller pieces of string that are all the same length with no string left over. What is the greatest length in centimetres that she can make them? So we have 18 centimetres and 24 centimetres. And we basically want to find the highest common factor of these two numbers because that's going to give us the greatest length that she can cut the pieces into, because both of those original lengths will be able to be divided with no leftover string. So if we start with 18, the factors of 18, we're going to have 1 and 18. We're going to have 2 and 9, we're going to have 3 and 6, and 4 doesn't work, 5 doesn't work, 7 doesn't work, 8 doesn't work, so that's what we've got. 1, 2, 3, 6, 9, 18. Okay, so now if we move to 24, we're going to have 1 and 24, we're going to have 2 and 12, we're going to have 3 and 8, because remember all these numbers multiply together to make 24, so 1 times 24, 2 times 12, 3 times 8. We're going to have 4 and 6, and then 5 doesn't work, 7 won't work, 9 doesn't work, and so on. Okay, now what we need to do is we need to look at these factors that we've got, and we need to find the highest one that is common to both. Okay, so the highest number that is in both lists. So if we look at 18, we've only got 18 on the 18 centimetre one, not the 24 centimetre, so it's not going to be that. It's not going to be 24 because that's too long for the 18 centimetre. We haven't got a 9 in both, we haven't got a 12 in both. Now 6 is the next highest one in 18, and we've also got a 6 in the 24. We don't have an 8 in the 18, so 6 is going to be our answer. 6 is the highest common factor of 18 and 24 centimetres. Okay, so that is our overall answer. Now, moving on to question 2, a similar kind of question here. A carpenter has two lengths of wood, one is 108 centimetres long and the other is 72 centimetres long. He wants to cut them up to produce smaller pieces of wood to build a shelving unit, so they all need to be the same length with no wood left over. What is the greatest length in centimetres that he can make the shelves? So a very similar sort of question, just with different numbers this time. So we've got 108 centimetres and we've also got 72 centimetres. Okay, so let's start with the 108. We're going to have 1 and 108. And I'm going to guess that we're going to have quite a lot here because we've got a big number, 108, so I've left myself lots of room. We've got 2 times 54. We've got 3 times 36. We've got 4 times 27. Now 5, that's not going to go into 108 because 108 will be divisible by 5 because it doesn't end in a 5 or a 0. What about 6? We've got 6 times 18. What about 7? 7, no, 7 not going to work. 8 is also not going to work, so a quick way to check that would be to put in your calculator 108 divided by 8, and if it's a decimal then we know it's not going to work. 9 times 12 is 108, so we've got 9 and 12. 10's not going to work because we haven't got a 0 on the end. 11 is also not going to work. If you do 108 divided by 11, or if you know your 11 times tables, you'll know that's not going to work. And then we're back up to 12, okay? So an easy way to check is just to do 108 divided by whatever the number. If you get a whole number, then that's going to be a factor. If you don't, then it's not. Okay, so we've got our list there of our factors of 108. Now our factors of 72. Okay, we are going to have 1 and 72. Nice, easy one to start with. We're going to have 2 times 36. We're going to have 3 times 24. We're going to have 4 lots of 18. Now 5's not going to work because it doesn't end in a 0 or a 5. We're going to have 6 times 12, if you know your 6 times tables. And last but not least, is 7 going to work? No, because 10 times 7 will be 70 and we've got 2 left over. But 8 times 9 will work. And then we try 10 we knew didn't work, and 11's not going to work if you know your 11 times tables because it's not 77 or 66. So there we've got our list of factors. Now we need to look for the highest common factor, so I'm going to start at this end of my list. Now 108, that's too big to be in the 72, so that's not going to work. And then we haven't got 72 in the 108. We haven't got 54 in the 72, but we have got 36 in both. Okay, so our answer is going to be 36 centimetres. And you might have spotted that as I was working through it. So if you spotted that, that's great. But I just wanted to go through all the possibilities just to double check, just to show the full working. But your answer is going to be 36 centimetres. Hello, so here we're going to be looking at the lowest common multiple questions. So let's start off with number 1. Helen's organising a party and she needs party plates and straws. There are 30 party plates in a pack and there are 120 straws in a pack. She needs the exact same number of plates as straws. What is the minimum number of each pack she must buy? So we've got a question here where we want to find the lowest common multiple because we want to find how many packets of plates we need that match up with the number of straws. Okay, so what we're going to do first is we're going to write out the multiples of plates. Okay, so if we have one packet of 30, we're going to have 30 plates. If we have 2 packets of 30, we're going to have 60 plates. If we have 3 packets of 30, we're going to have 90 plates. If we have 4 packets of 30, we're going to have 120 plates. Now I'm going to stop there. And if we go to straws now, 1 packet of straws is going to be 1 times 120, which is going to be 120, and that matches up with 4 lots of plates. Okay, so that's going to be my lowest common multiple because that's the lowest amount of straws that I could possibly get, and then that matches up with number of plates. Okay, so I want 1 packet of straws and 4 packets of plates. So my answer is going to be 4 packets of plates and 1 pack of straws. Okay, moving on. Question 2. A school purchases workbooks in packs of 25 and textbooks in packs of 15. The school needs exactly the same number of workbooks as textbooks so that they can be paired up for the students. What is the minimum number of each pack that must be bought so that all the books are paired? Okay, so similar kind of thing here. We want to find a combination where we have the workbooks matching up with the textbooks. So we're going to start off with the workbooks. And we can see that they come in packs of 25. Okay, so we're going to have 1 pack of 25 is going to be 25. 2 packs of 25 is going to be 50. 3 packs of 25 is going to be 75. 4 packs of 25 is going to be 100. Now I'll stop there and then I can always work further on if I need to, but I'm going to check the textbooks first so I don't have to do lots of unnecessary work. So textbooks. How many textbooks? Textbooks in packs of 15. Okay, so 1 lot of textbooks is going to be 15 textbooks. 2 lots of textbooks is going to be 30 textbooks. 3 lots of textbooks is going to be 45 textbooks. 4 lots of textbooks is going to be 60 textbooks. Now we still haven't got a match yet. 5 lots of textbooks is going to be 75 textbooks. And look, we've got a match because we've got 3 lots of workbooks and 5 lots of textbooks. And we haven't got a match before that, so that's going to be our lowest common multiple. Okay, so our answer is going to be 3 packs of workbooks and 5 packs of textbooks to give us 75 of each. Okay, so they're just some examples of when we would use lowest common multiple in real life situations and real life problems.